All right, we are still in week 3. We're going to go over a little bit of statistics, and not, again, this is not necessarily a statistics course, but again, statistics just help us take some of our linear relation things and put them into kind of a real life setting. So this is not statistics per se, it's more statistics relating to linear relations. So in this video, we're going to go over how you can use Google Sheets to do some statistics things. We're going to go over the correlation coefficient and what that means. We normally call that R, that's why I put that there. We're also going to go over the coefficient of determination, which we call R squared. We're going to go over what that means as well. So to do this, I'm going to show you from Google. If you're in your Google account, this is how to go use your Google Sheets to create a scatter plot. So first thing you're going to do, this is my Google account. I'm going to hit New, go to Google Sheets. This is my new Google Sheet. I can call it what I want up here, where it says Untitled. I can just say New or something, call it whatever I want. Now again, we are working in a spreadsheet form, so all of these cells are a different spot. If I am right here, we would call this D3. Or if I'm right here, this is B1. So we have all of our columns, all of our rows. We're going to make a quick spreadsheet on age and height. And I'm going to put this height in centimeters. I'm going to lowercase those centimeters. So our age is going to be years, our height is going to be centimeters. So let's say I have a kid who is 11 and they are 130 centimeters. Another kid who is also 11 and 141. Instead of maybe going through and doing age and then height, I'm going to get all of my ages first. So 11, 11, another 11, 12, 12, and so on. I'm going to get a couple of these put in. Bear with me here. Now I'll have to go back and do all of their heights. So I had 137, 141, 144, and so on. Give me just a moment here. What we're doing here is basically just grabbing all of our data, getting it together in tabular form, so just a place that we can look at it, and basically we are making a relation. This is again just a set of ordered pairs. You can see that everything on the one side, the age is kind of like our x, the height is kind of like our y, so all of these ordered pairs like 11, 137 or 12, 160, each of these is one piece or one person. So one person that we checked was 11 years old and 137 centimeters. We collect all of this together and this creates a relation. Again, all of our domain, our input over here, our range, our output over here. With this table then, again, yours doesn't have to be exactly like this if you are making your own, and you can type them up, or a lot of times you can find data that is given in table form. You can just copy and paste it in here. So we're going to pretend that we are working with this data, and I'm going to show you how to make a scatter plot. First, I'm going to have you highlight all of your data. You can include these headings. You don't have to get rid of them. Google is smart enough to know that these are just headings. Everything else is the actual values. Once everything is highlighted, you hit Insert and go, Insert and drop down to Chart. Now it might give you a different kind of chart right away. Yep, mine gave me a bar chart. So again, just kind of a visual representation. This person was at 11, they're this tall. 11, they're this tall. 11, they're this tall, and so on. We are not looking for a bar chart this time around. So I want to come over here to my chart editor, go to Chart Type. I'm going to scroll down to a scatter plot, okay, or a scatter chart. This is what we're looking for this time around. Again, now this is looking much more like one of our, move this up here, this is looking a lot more like one of our relations. We have all of these ordered pairs, all of these points, all across our graph. So again, here was our table form, here was our graph form. However, you will look and see that our graph is not necessarily a linear function. By that I mean it's not going to create a straight line. This can, however, make a pretty close linear guess. We would call that a linear regression or a regression line. To find this linear regression line, there is a fair amount of work, a fair amount of process behind it, or you can just have Google do it for you. So while we are still looking at this table or at this chart, I can just come over to Chart Editor. Now if you ever lose this screen, let's say this got closed out, you can just click on your chart, click these three dots, and do edit chart. It'll bring the chart editor back up. Okay, so again, we already changed it, clicked onto scatter chart. This data range, again, remember this is all of the things that we had highlighted. Now I'm going to go to customize. From customize, I'm going to click on series. These are all a bunch of different things you can be looking at. For right now, I just want to look at going to series, and we are going to add in a trend line. Now this trend line will create a linear function, a line, that is pretty darn close to our relation. Again, we gave just a bunch of data points. It's going to estimate or give a linear regression line for those points. Okay, again, our type was linear, meaning that it's a line. You can change it to some other pieces. We're going to leave it on linear for now. The label for this line, we are going to put on the equation. Use equation, that way we can see the equation here for this line. I'm also going to have you click on the show r squared value, and we'll go over that in just a little bit. So, close out of this. This point, again, we took our table of all of our inputs. So again, all of these kids age 11, 12, 13, 15, 16, 17, all of their heights. You can kind of see that as kids get older, as our age increases over here, they seem to be getting taller. Their height seems to increase as well. But it's not all that closely related. So up here, I'm going to type in, correlation, just one L, COEF, as in correlation coefficient. So I'm going to figure out what my correlation coefficient is. So how I do that is, again, I just have Google do it for me. Just like Google found out this equation for the line here, I'm going to hit equals. That tells Google that I'm about to type in a formula or a function that it can run for me. I'm going to basically be typing correlation. So when I start with C, notice that it brings down a bunch of drop-down options. Things like the cosine of an angle, or the hyperbolic cosine, or the count, or covariance of a data set. C brings all of these options. So I'm going to continue with CO. Again, cotangent, column. Here's one, CORREL. If I wasn't sure exactly what function I'm looking for, I can start typing it and see what pops up. Pearson product moment correlation coefficient. This is, in fact, the correlation coefficient we're looking at for. So, CORREL, again, that gives us our correlation coefficient. We need to tell Google, however, what we want that coefficient of. So we type in a parentheses. It is now looking for all of the data we're going to be looking for. We need to tell Google what we want the coefficient of. So I'm going to do the first one with a drag. I'm going to click the top age and drag all the way down to the bottom one. Notice it plugs in for me A2. So again, that was this box, column A, row 2, with a little colon here, A15. We're telling Google our input is always going to be all of the pieces in this column here. Now I'm going to put a column to separate them. Basically, we're telling Google we want the correlation coefficient of these x values and these y values. Now again, I could click and drag. I'm going to show you that I can also type. I can just type B, and notice mine is even lowercase. I'm going to go B2, type in that colon, B15. And you can see that Google kind of highlights my inputs are all of these orange ones, my outputs, or my x's and y's. Y's are these purple ones. Close my parentheses. Remember, you always have to close a parentheses. Be very, very careful on this. Go ahead and hit enter. There is my correlation coefficient. Again, we called this R. We looked over that a little bit at the beginning slide. So, took all of this data that I typed in, made a scatter plot, found the trend line. Here's the equation. It might be kind of hard to see, so I'll retype it as y equals 7.2x plus 68.514. Now again, all of these data points, these little plots here, this relation is not necessarily a linear function. However, on this line, anywhere here, we can write it in our slope-intercept form, y equals 7.2x plus 68.514. This now looks like a linear relation. Here we can see our correlation coefficient is about 0.8, a little bit extra. We can see our coefficient of determination over here is our r squared, that is 0.641. So I'm going to go over what all of that means then. Coming back to my slides. After we just ran all of that, we figured out all of these tables and different things on Google, we're now going to see that the correlation coefficient, or what we call R, is just a number between -1 and +1 that represents the connection between two variables in a set. The sign of R is the same as the sign of the slope. So if R is negative, your slope is negative. If R is positive, your slope is positive. So let's double check that. I want to come back to Google. Our correlation coefficient R was a positive 0.8. And so here we can see we have a positive slope. It is trending upwards. So that's how the signs work. The farther the value is from 0, the stronger the connection between the variables. So again, the closer it is to either +1 or -1, that's a very strong connection. The closer it is to 0, it's a very weak connection. So again, I just want to look at what that means. 0.8 is pretty darn close. We can see that, yeah, some of these are pretty far away, but they're also fairly close. This makes a pretty good connection. We can definitely see all of these are really close to this line, so that's a pretty good line. If we had dots going everywhere, and there really wasn't a good line or a good guess, we'd have a much lower correlation coefficient. One thing to remember, R is not the slope of the line. Some people, when they're first learning this, they make the mistake of, oh, here's my correlation coefficient. That must be my slope. So when they write their equation, this one over here, they'll use this. That is not true. Notice 7.2x, 7.2 is our slope. Correlation coefficient is 0.8. Okay, there is no connection there. This is not your slope. To go over a little bit more of what these look like or how this all works, I'm going to give you or show you a couple more tables that I've done already. This first one, we can see we have a few students. This was their ACT composite score before going to college. This was their GPA at the end of college. Notice we have kind of a slightly trending upwards line. Our correlation coefficient R is a positive number. This means that, yeah, there is a little bit of a connection. The higher your ACT score, you're probably going to have a higher GPA at college at the end. But notice that it's a really low. It's 0.4. It's less than 0.5. It's less than a half. So even though there's a small connection there, really what this is telling us is it doesn't matter what your ACT score is. At the end of college, your GPA can be pretty much whatever. There isn't necessarily a very strong connection there. However, if there was a connection, there'd definitely be positive, meaning higher ACT, higher GPA. Let's look at another one with ACT scores and scholarships. This one, we can see again the same ACT scores and how much money they earned for scholarships. Now when you look, all of these data points here are pretty darn close to that line. And we can see that our R value, the correlation coefficient, is 0.98, meaning it's very, very strong. These points are very, very close to this line, basically saying, yes, it is both positive, so the higher ACT, the more scholarships you will have, right, because they're both trending upwards. It also means it's very, very close, meaning there isn't a whole lot of variance from that. If you get a really, really high ACT score, you're almost guaranteed to get high scholarships. And if you have a very, very low ACT score, you might not get a whole lot of scholarships. So again, you can see there is the connection here. When the dots or when these points are really close to the line, you'll get a higher R value, or closer to 1 or -1. I'll show you another one where we go negative. Again, we're looking at age of children, so 3, 4, 3, 5, 4, and so on. So with this just a bunch of kids and their ages, this is how many times they wet the bed in a week. You can see that as the child gets older, as the age increases, they're wetting the bed less times, or so we would hope. So we can see here, this is trending downwards. As it trends downward, we still have a pretty strong correlation coefficient of 0.85, but it is negative. That negative means it's going downwards. So again, the slope of this one would be negative or going down. Lastly, we're going to go over that coefficient of determination. That is the R-squared value. We saw that on each one of those, or at least you can turn it on from that the edit function. The correlation of determination is just found by squaring the correlation coefficient. So over here, if you found R, remember that's somewhere in between -1 and 1, you just square that, and that's how you find R squared. Big surprise. This value basically helps us explain how the difference is affected, or by how much, we should say. The R squared is the percentage of the difference that can be explained by our model. Now notice this is not the percentage of points that are actually on the line. So if I come back to this, again, our R squared value is 0.739. Okay, basically saying that 74% of all of this difference in between here can be explained by the age. So if you want to know, like, I wonder what's making these kids wet the bed more or less. Well, 73% of what makes them wet the bed more or less is dependent on the age. There are other things that affect why kids wet the bed that cannot be explained or have to be explained by something else other than age. Age is only accounting for about 73% of why kids are wetting the bed more or less. If we look at, again, the scholarship, we would say, I wonder what affects how much money kids get for scholarships. Well, again, this ACT composite score, if we look at the R squared value, R squared is 0.973, meaning about 97% of why these kids are getting their scholarship is their ACT score. So again, having a good ACT score really shows up, or really counts for getting a scholarship. Does it count that much for GPA though? Your ACT score, as opposed to your college GPA, well, that R squared value was 0.234, meaning about 23%. So if you were wondering, why did this person get a really high GPA or a really low GPA by the end of college? Well, you could explain some of it because of their ACT score, but you can only explain 23% of it, meaning there are probably other factors. So again, we've now gone over, using Google Sheets for statistics, what is the correlation coefficient and the coefficient of determination. Make sure you're asking questions if you have them, otherwise have a good one.